Okay, now that you hopefully feel really confident identifying the sine, cosine, and tangent as fractions, let's talk about some cool things that come once we know the sine, cosine, and tangent. So first of all, let's take a look at these three triangles that you have in your notes here. In this blue text on the top, you can see that I found the sine of 20 degrees. Notice that each of these triangles are a different size, but they all have that 20-degree angle. These are all similar triangles, if you remember from our last unit, because they're all right triangles, and they have a 20-degree angle. So by angle, they all are similar triangles. So what we've done here is we've looked at the fractions opposite over hypotenuse for each of these three distinct triangles. And the cool thing that you'll notice is that when you did that, you got the same fraction, the same decimal for all of them, 0.342. So let's do that same thing but with the tangent. So with each of these fractions, we're going to identify the tangent of 20 degrees. So the tangent of 20 means that your theta is going to go down here by the 20. Let me change to a black pen. The theta goes down here by the 20. Let's label our sides, hypotenuse, opposite, adjacent. The tangent, SOHCA, TOA, is the opposite over the adjacent. So in this case, it would be 6.52 over 17.9. Well, let's divide that and figure out what it is as a decimal. So 6.52 divided by 17.9, that is 0.364. We'll just round to 3 decimals. All right, next triangle, we're going to use the same 20 degrees for my theta. We can label opposite, adjacent, hypotenuse, and the tangent will be 8.26 over 22.7. Let's put that into our calculators. And we get 0.364 again. And then the last one, we're again going to do the opposite, so 9.83 over the adjacent, 27. And we get 0.364. So this is the cool takeaway. It does not matter how big your triangle is. The tangent of 20 is always 0.364. Tangent of 20, oh, why did my pen just stop working? The tangent of 20 is always 0.364. So if you want to know what the sine, cosine, or tangent is of any specific angle measure, you actually don't even need a triangle. You can just use your calculator. So get a calculator. If you do not have a calculator that has a sine, cosine, or tangent on it, you're going to need to borrow one of mine. So go grab them. You are going to find on your calculator where it says sine, cosine, or tangent. It's usually right above where the number pad is. You'll see the sine, cosine, or tangent. And you're going to click sine of 20. Hit the sine button, type in 20, hit enter. You should get 0.342. Now, if you didn't get 0.342, it might be because your calculator is in the wrong mode. So if you got 0.9129, that means your calculator is in the wrong mode. So what you need to do is you need to click on your calculator where it says mode. It's usually on the top left of your keypad somewhere. It's on my calculators, it's right up next to the second button. Hit mode, and then somewhere on there it's going to have radians and degrees. It's on my calculators, it's the third option down. You're going to go over and make sure that the degrees is highlighted. So hit degree, go over to degree, hit enter, and then hit clear just to X out of that screen. Once you're in degree mode, your calculator should give you 0.342 for the sine of 20. Okay. If you're having trouble with this, hit pause, ask someone next to you, or ask the teacher, how can you get your calculator into degree mode? Do not use your phone calculator for this. I would not use my phone calculator for doing any sort of sine, cosine, or tangent. So what we're going to do now is we are going to say, okay, if we know that every angle gives you the same decimal, right? The sine of 20 is always going to be 0.342. We're going to go kind of the opposite direction. what if I know the side lengths? Could I figure out what the angle is? So to do that, we're going to introduce what's called the inverse trig functions, which look exactly the same as the regular sine, cosine, and tangent, but they all have this little -1 up in the top right corner. And here as how we use them. Let me get a blue pen out. So let's say I have my angle theta, and my goal in this question is I want to know how many degrees is theta. Is theta 50 degrees? Is it 30 degrees? Is it 37 degrees? That is my goal here. So what I'm going to do is I'm going to have my theta. I'm going to label my side lengths to start off with. Hypotenuse, opposite, adjacent. Now notice that I don't know the opposite side length, and I could figure it out using Pythagorean theorem. So let's kind of keep that in the back of our minds. If we need to, we could find the opposite. But what I do know is I know the adjacent. Actually, I'm going to do this in a box instead of. I know the adjacent, and I know the hypotenuse. Okay? So I'm going to think back to SOHCAHTOA. I'll write it up here. Told you this is going to be really important. Hopefully it's burned in your brains by now. And I'm going to think, okay, which of those three ratios deals with the adjacent and the hypotenuse? And that's the cosine. I know that the cosine of theta is equal to the adjacent over the hypotenuse. So in this triangle, the cosine of theta is 10/16. Now here's the cool part. I want to know what theta equals. So what I can do is I can switch this to the inverse cosine. So the cosine with the -1, and that basically switches my equation around so that the theta is by itself. I can say the inverse cosine of 10/16 is equal to theta. Now, you're like, awesome, that doesn't get me any closer to anything, but it actually does. Look at your calculator, find where your cosine button is. Right above that, printed on your calculator, you should have an inverse cosine, that cosine with the -1. So hit your second button and then the cosine, and you should get that cosine with a -1. Type in 10/16, and you're going to get 51.3. That is the measure of theta. So that angle theta is 51.3 degrees. Okay. If you couldn't find those buttons on your calculator, pause the video, ask someone next to you, figure out where these buttons are so that you can make sure that you know how to type this in. Okay, let's do another one. So my goal here is to figure out what this theta is right here. So let's label my side lengths. Hypotenuse is across from the right angle. Opposite is across from the theta. And then adjacent. So in this case, I know the opposite and I know the adjacent. So I'm going back up, I'm thinking of SOHCAHTOA, which side is the opposite and which side is the adjacent. Which of these three ratios deal with opposites and adjacent? That's the tangent. So we're going to say the tangent of theta is equal to the opposite over the adjacent. Then I'm going to switch this to the inverse tangent. So the inverse tangent of 11/4 is equal to theta. Type that into your calculator, and theta is equal to 70.0 degrees. All right, let's do another one together. We'll do a couple more. We will not go through every example here. You'll get some more practice in your homework today. So go ahead and take a look at where your theta is. That's your first step. And label your sides as opposite, adjacent, and hypotenuse. Then you've got to look at what you know. You know the hypotenuse. You know the opposite. So that's going to be how you decide if you're going to use sine, cosine, or tangent. So in this case, if I know the opposite and I know the hypotenuse, well, the opposite and the hypotenuse go together to form the sine. So we're going to use the sine for this one. So the sine of theta is always the opposite over the hypotenuse. So then to find the angle, I would do the inverse sine of the opposite over the hypotenuse. Type that into my calculator. Oops, that should be theta. And theta is equal to, it's 64.99, which is going to round up to 65 degrees. Okay, if you're feeling pretty confident on this, that you could do problems like this, go ahead and stop here and move to the second page of your homework. You're going to do numbers 10 through 18. If you want to see a couple more examples, hang out here and I'll go through the next couple examples together. So I want to find my theta value. So I'm going to label my sides opposite, hypotenuse, and adjacent. So if I know the opposite and I know the adjacent, I think back to SOHCAHTOA. The TOA has the O, the opposite and the adjacent in it. That's the tangent. So the tangent of theta is equal to the opposite over the adjacent, which means the inverse tangent of 12.9 over 4 is equal to theta. I'm going to type that into my calculator. And theta will be equal to 72.8 degrees. Okay. Theta in my next one. Trying to find what angle B is. Label my sides first. So the side across from my right angle is the hypotenuse. Across from theta is opposite. And then adjacent. I know the opposite. And I know the hypotenuse. I know that opposite and hypotenuse come together to form sine. So the sine of theta is the opposite over the hypotenuse, which means the inverse sine of the opposite over the hypotenuse is equal to theta. Punch that into my calculator, and my theta is equal to 32.6 degrees. Okay. Now, after seeing those example problems, I'm ready for you guys to practice on your own. So jump to your homework. You're going to do numbers 10 through 18. Okay? When you finish those, come back and watch the next video.